All right, this is problem 60 from the chapter on lines and planes, equations for lines, equations for planes. They asked for the symmetric equations of a line which is the intersection of these two planes. You can tell these two planes are not parallel because the coefficients of x, y, z are not the same or multiples of each other. So these two planes intersect. The two planes are going to intersect in a line. Symmetric equations, remember, are the form of x minus x sub 1 over a equals y minus y sub 1 over b. You can see why they asked for symmetric equations, because these planes are the only way we have to write planes in terms of x, y, and z. So I've got two planes in terms of x, y, and z. Why not just use x, y, and z instead of the vector notation for this line? Now notice we have both equations of planes have z equals. So the first thing to do is cash that in. So we have 2y minus 5 equals z, which must equal 4x plus 3y minus 5. Now I knew to do that for two reasons. One, I had z equals in both. I feel like it should be the right thing to do. But it is the right thing to do because I now have an equal sign with a relationship between x and y. That's this. Here's a relationship between x and y. All I have to do is make it look like this form, and I have this much of the symmetric equations done. So I'm going to subtract 2x. So I have 2x divided through by 4, because that gives me, in my numerators, just, y over negative 1, put it that way, is equal to x over 2. So it's y minus 0, x minus 0, and then under the x there's a 2, and under the y there's a negative 1. And now all I have to do is get z into the equation. Well, there's a nice little path here, because remember, this is negative y, and I have negative y right here. I've got a match. So I've got a relationship between x, y, and z, and I already have an equation for y in terms of x. So I can substitute for x over 2. I can get this to be a y thing, this 2x, and the negative y, that's negative y. I can have that be x over 2. Well, I'll just leave the 2x then. I have 2x, negative y is x over 2, so that's plus x over 2, minus 5 equals z. So that's 5/2 x. Let's make this z plus 5 is equal to 5/2 x, and I get the 5 to the other side. And I really want x over 2, because then I can say x over 2 is equal to whatever I get. Well, I have x over 2, just divide by 5. So how could you tell? How could you convince yourself that this is the right answer? What could you do? And here's what we did in class. We can generate ordered triples. We can generate points that are on this line, and then check that those points if I could just make ordered triples out of here. So let's say all of these equal 3, and I'm pulling 3 out of thin air. Now for this to be so, this 3 really doesn't matter. It isn't anything. It isn't x equals 3 or anything like that. But it's the value that all 3 of these fractions take, so that all 3 fractions are equal. But here's the ordered triple that makes that so. Now let's check to see if this ordered triple works in this equation over here. So I'm putting in 10 for z, 10. And I wonder, does that equal 2 times, what am I putting in for x? 6. I'm putting in for y, negative 3. So it's minus negative 3, minus 5. Well, let's see if that's true. Is equal to 4 times x is 6 plus 3 times negative 3, so it's minus 9, minus 5. Where we are. And don't forget, quiz number 1 is in the books. And that's the vector, scalar, or nonsense quiz. So keep working in this section, planes and lines equations. Do problems.